today we will talk about the amorphous solids, right? So in my previous video, we discussed the crystalline solids, basically the classification of solids into crystalline solids and amorphous solids. So today we will discuss about amorphous solids. So as I said to you in my previous video, that amorphous solids are not real solids. These are known as pseudo solids, right? So basically, they have, like as I said, the crystalline solids have a regular arrangement. But as you can see in the given diagram, here we have a regular arrangement, right? But in the amorphous solids, there is no such regular arrangement. So you can say that there is irregular arrangement. So the irregular arrangement of the atom, or you can say the constituent particles, right? We won't say here atoms, molecules, ions. We will say constituent particles, right? So basically, the irregular arrangement of what? Constituent particles is known as amorphous solids. So as you can see over here in this given diagram, over here you can see there's an irregular arrangement. This is regular, but this is irregular arrangement, right? This is what? This is irregular arrangement. So this irregular arrangement is known as amorphous solids, right? So basically, they don't have regularity in very long range. They have regularity in a small range. What does that mean? Let me write it. They have regularity in small regions. It doesn't have regularity for long orders, right? So for example, over here you can see over here there are there are three constituent particles which are arranged regularly, right? So basically but over here the about these molecules, they are not arranged in a regular form. So it means in amorphous solid they have regularity, a little regularity, but in what? In small regions. In small regions, right? They have regularity in a small region. So basically this regularity in a small region, basically let me highlight this like with this. The regularity in a small region is known as crystallite. Now these structures are basically known as crystallite. These are known as crystallite. These are known as, sorry, these are known as, let me fix this. So where we were, so these are known as crystallites, right? So now this small regularity in a small region is known as crystallite. Now basically these amorphous soils are known as supercooled liquids. They are known as supercooled liquids. What are they? They are not solids actually. They are super cool liquids. These are actually liquids which are freezed at a certain point that they become solid, right? So these are what? These are super cooled liquid. When we talk about the melting point of these amorphous solids, so basically they don't have sharp melting point. What does that mean? Basically they have a range. They have certain range of temperature, because as I said there is no such regular arrangement. So every molecule need different temperature. For example, there in crystalline we have a regular arrangement, so every molecule needs same temperature to get melted, right? But over here this molecule need another temperature, these molecule need another, these need another. So that's why they have a range. For example, 150 to 156, 200 to 201. So this is known as a range. There is a range of temperature. There is no such fixed sharp melting point, right? So now, okay, whenever we cut the amorphous solid with a sharp edge knife, like whenever we cut, we have, when we cut amorphous solids with sharp knife, we get an irregular edge, or you can say irregular cut. So whenever we'll cut, so basically whenever we'll cut these amorphous solids with a sharp knife, we will get an irregular arrangement. For example, if we cut this, consider if we cut this. For example, let me erase this. For example, okay, here is a knife and I'm cutting this. So as you can see, there's no such regular arrangement, right? The particles are arranged irregularly. But if I'm cutting this crystalline solid, there is a regular arrangement, right? They are making symmetry, but this is not making symmetry. So it means there is a irregular cut, right? Okay, there are a lot of examples of amorphous solids. For example, we have glass, which is basically made up of silicon dioxide. So glass is basically made up of silicon dioxide. We have rubber, we have plastic, even the charcoal is also amorphous solid. As you can see over here, this charcoal is amorphous solid, right? Now basically, the as I said, these are super cool liquids, so they have an arrangement like liquids. Okay, they have their constituent particles are arranged like liquids. Their arrangement is like liquids, and they have capability to flow. They have capability of flowing, right? So as I said, these are basically their arrangements like liquid. They are so super cool liquids. So obviously their arrangement will be like liquids. So they have the capability to flow. Okay, how you can observe this capability of flowing? Basically, whenever in old houses, maybe you guys have observed, like in old houses, in the basically the windows, the bottom becomes thick. For example, okay, this is a window, right? This is a street. But after some time, the actually the bottom becomes thick. The bottom becomes thick, and the let me draw it again. Okay, I'm not good at drawing, but this is what I can make. So the bottom basically becomes thick. The bottom becomes thick. Why? Because with time, because under constant influence of gravity, these windows of very old houses becomes thick at the bottom and thin at the upper side of, right? So this is flowing towards the gravity. This shows the flowing flowing towards gravity, like under constant influence of gravity, right? So the thick, like the end becomes thick and the so basically the end becomes thick and the upper side becomes thin. So I hope this amorphous solids are clear to you. These are the some properties. We will discuss about some more properties in my upcoming videos. And if you guys have any kind of queries, you can ask me in the comment section. I will be very happy to answer you guys.